So now we'll discuss another topic, which is digital receiver and regenerative repeater. So what is the difference between receiver and regenerative repeater? The major difference is that receiver is basically a regenerative repeater, but it is used at the end user side. It won't send something back to the someone else. Rather, it will convert whatever information it received into desired form. For example, if voice is sent, then bits will be converted into voice form. If image is sent, then the output of that receiver would be image, and so on. However, regenerative repeater is and in another way, regenerative repeater is also a receiver, but the difference is that it basically takes the signal, regenerate the pulse. So this is a pulse, it regenerates as a fresh pulse and then sent to the another receiver. Now what is the structure? So which means that these two terms have common component, except one will keep sending to the next part, that is regenerative repeater. However, receiver will not send it to someone else, rather will convert the information into desired form. Now what is the structure of regenerative repeater or a receiver? So the structure is, this is the transmission medium. So first we have a transmission medium wherein the noise get added. So whatever information we are trying to send is basically distorted with the noise or distortion. The difference between noise and distortion is that the noise is external source rather, and on the other hand, noise usually comes from a source which can be external, which can be internal. However, distortion is because of non-linearity of medium, devices and components, etc. Then we have amplifier or equalizer. So signal which is received, so our receiver starts from this side. So the signal which is received is first amplified. It is as good as you come back after whole working day. When you come back, your mother or you yourself take some juice, so you get some energy. So it is same as amplifier. It amplifies the signal, gives you the signal strength. And then we have used something which is called as an equalizer. What is equalizer? Is an important component in communication, is an important device in communication. We'll discuss more on this. Then we have clock recovery. As we know that in digital communication, if someone asks what is the difference between analog and digital communication, the major difference lies in digital communication, we must dedicatedly have clock both at the transmitter and receiver, while it is not the case in analog communication. Clock is necessity in digital communication. Again, there are two types of recovery, clock recovery. One is to know that the start and end of the bit, and other is to know the actual sampling instant. So sample and decision making is a important part, as we have discussed. The signal which is received will have some label as. This label will be compared with threshold lambda. If it is greater than lambda, we'll decide in favor of bit 1, else we'll decide in favor of bit 0. So now where to take decision, that particular instant has to be there. So that instant will be how we will know that what is that particular instant. So that is useful in decision making, and this is done through clock recovery. And we'll discuss in the unit 3 that TB is the instant at which your decision making is optimal, and after that we have pulse regenerator. So as we've seen, for s greater than lambda you get 1, else you get 0. So 1 means you need to generate a pulse of V volt, and 0 means you need to generate a pulse of minus V volt. This is what the meaning of pulse generation, and this pulse is sent again to the next regenerative repeater. This process will keep repeating unless and until we get our receiver at the user end. Now in this whole structure, there is something which is called as an equalizer, that we came across something which is called as an equalizer. So what is equalizer? Equalizer is something, as the name suggests, that equalizer equalizes something. So to understand the role of equalizer in communication, let us consider a channel that is shown here in the figure 1. This is ideal channel. The response is ideal because it is a flat, and it is flat till omega c. Then after it is going down abruptly, which is not a practical case. So in 2 we have shown some practical channel. So the practical channel may have shape like this, or it may be something like this, some skirt would be there. So you can see some the response from omega c, minus omega c to plus omega c is not a straight line. It can be something like this also, okay, or it can be some different shape. But to understand equalizer, let us assume this particular shape. Now if that is the case, if my response is like this, from minus omega c to plus omega c, then what is the problem? Problem is that my signal will get distorted because my response is not a straight line. My channel response is not a straight line, that is why signal will get distorted. That is, at f is equal to 0, its gain is maximum, and as we are moving from omega 0 to omega c, then gain of the signal will reduce. So it will change the property of the signal. So the signal which is coming at the output of channel will not be a linear signal, will not be the signal same as was inserted at the input. So this will cause distortion. How to remove this distortion? So what if we use something at the receiver with the response like this? Now what is important here is this response in the figure 3 is exactly opposite to the response in the figure 2. That is, in one case we are using this response, in another case we are using this response. So what is the cascading effect? That is, a signal which is passed through this is applied at the input of this, then what will happen? This effect will be nullified by this effect, and we will get a flat response. And this is what equalizer do. So what is shown in figure 3 is basically the transfer function of the equalizer. So what is equalizer? Equalizer is something which basically equalizes the distortion which is introduced by the channel. So what type of distortion? Distortion can be anything. It basically can be any shape. It can be of any different shape in the left and right side. And the first step would be to know the type of distortion, and second step would be to basically design the response, design your transfer function in such a manner that it is exactly having opposite shape as that of distortion, so that it equalizes. This is the basic purpose of equalizer. So I'll repeat, equalizer is something which equalizes the effect of distortion of the channel. And how does it equalizes? It equalizes by having the transfer function which is just opposite to that of the channel. Now in the next lecture we will see another type of important equalizer, that is zero forcing equalizer. What is zero forcing equalizer? Why is it used in communication? What is role in communication? That we'll discuss in the next lecture.